Hello, Math 2 students. This is the third lesson in our unit on transformations. This is grading period 1, which you see that's what that 1 stands for. Week 2, lesson 3. We have already done dilations and translations in this unit, and we remember that we have a pre-image and an image, sort of a before and after of our shapes and figures. Today we're going to talk about reflections, and I want you to just think about what the word reflection means. When I hear the word reflection, I think about looking in the mirror and creating a mirror image. That's what we're going to be doing, but we also want to talk about the fact that we are flipping that image over a line. Okay, so let me show you two images here. So this image on the left, this is Mount Hood in Oregon, and then this image on the right is just a beautiful watercolor image. And in both of these pictures, the image has been flipped over a line, and you see that there's a mirror image of it. If you look at the one of Mount Hood here, so I love this picture. The Mount Hood looks like it has been flipped over, and it's upside down in its reflection in the water. And over here on the right, this watercolor image, this face looks like it's been flipped over, and there's a mirror image of it on the right side from the left side. So if we look at the one of Mount Hood, what we can see is that it looks like there's a line. Let me grab a line here. It looks like there's a line where it's kind of been flipped over that line, and we could define that line somewhere along here. So it looks like Mount Hood, the mountain, and all the trees have been flipped upside down across this horizontal line. So if we look at the one on the right, the face hasn't been flipped upside down, but it has been flipped to a reverse or a mirror image. And the line that it's reflected across in this image is about right here. And so Mount Hood has been reflected across a horizontal line, but this face on the right has been reflected across a vertical line. So it is possible to have a reflection across many different lines. These are just two examples. And if you think about in math, on the coordinate plane, we have a horizontal line that we call the x-axis, and we have a vertical line that we call the y-axis. So what this shows me is that an image could be reflected across a horizontal line or a vertical line. We're also going to talk about reflecting across diagonal lines, but let's first look at the horizontal lines and the vertical lines. I want you to look at a triangle that I've put on this coordinate plane. Let's call this triangle the pre-image. Let me get a different color. Keep it the same color. So this black triangle is going to be our pre-image. Let's name our points A, B, C, and let's talk about what the coordinate pairs for these vertices are. So A would be at 1, 7. B is at 7, 1. And C is at 1, 1. All right, so I'm going to take this same triangle and I'm going to clone it. I'm going to make a copy of it. Okay, so there's a copy. I'm going to just move it over here somewhere because I know what I want to do is I want to flip it across this y-axis and show what that looks like. So let me go up here. Whoops. Go up here, and what I want to do is I want to flip this thing left to right. Okay, so there is a mirror image of this triangle, but I want to make sure that it's been reflected across the y-axis, that horizontal axis. Okay, and then what I'm also going to do is change the color of it so we can talk about these different triangles and know which one we're talking about. So the red triangle is a reflection of the black triangle across the y-axis. So let's name the image. So we have our pre-image, our before. We're going to name our image, which is our after. So if this thing flips, the A prime is right here. The B prime has flipped all the way over to here, so it's right here. And then the C prime kind of stays close, it's right here. So if you imagine this triangle flipping across the y-axis, this B is going to end up way over here. So let's talk about what those coordinates are. I want to look at the difference in this coordinate pair and this coordinate pair and see if I'm seeing a pattern. And the pattern that it looks like I'm seeing when I reflect across the y-axis here is that the x coordinates have all changed to their opposites. So the digits, so to speak, the 1, 7, 1, 7, 7, 1, 7, 1, and all that, they've stayed the same and in the same order. But the thing that's changed is that my x coordinates have all changed to the opposite of what they were. So now I think I'm going to take this triangle and flip it across the x-axis instead of the y-axis. So I'm going to clone it again, move it down here, get it where I think it needs to be. And this time I'm going to flip it up, down. All right. So, and then I'm going to change the color. Let's change this one to blue. Okay. So I have flipped this thing across the x-axis this time. And let's look at the coordinate pairs for this. So this time C will be here, or C prime will be here. Let's do like C prime prime on that, because these are the first image, and then our second image is going to be the blue one. So our pre-image is still the same. It's still the black one. All right, so then my A is going to be or A prime prime is going to be all the way down here, and then the B prime prime is going to be right here. So let's talk about what those coordinates are. So, okay, so what happened this time? When we went across the x-axis, it looks like the y's changed to their opposite. So maybe we can talk about some rules here. So when you reflect across the y-axis, let me change this to red because that's what we did. The red one is across the y-axis. So when you flip or reflect across the y-axis, it looks like the x values change to their opposite. In other words, if it's a positive, change it to a negative. If it's a negative, change it to a positive. So everything stays in the same order, you just change the x values, okay? When we flipped across the the x-axis, that made the blue triangle. I'm not going to try to put any more on here. When we flipped it across the x-axis, the y values changed to their opposites. So y values change to their opposites. And I think this is a pretty accurate pattern. So I think we could probably state that these are the rules for when you reflect across the y-axis and across the x-axis. So let's go ahead and start on your notes. If you want to go ahead and get your notes out, we'll start on those, and then we will look at those diagonal lines in a minute too. Okay, lesson title is Reflections. And if you want to give it a number, it is 1.2.3. So a reflection would be the process of flipping. So it's not sliding. You remember translations were sliding. Of flipping a figure. So let's look at the first example on your notes. I'm going to give you a set of ordered pairs for the figure that we're going to construct. It's going to be a rectangle. So we have A, B, C, and D. -3, -1, that's A. -2, -1, B. -2, -2, C, and D. And so let's just draw this little square here. Okay, so that's our pre-image. And then our image is going to be over here. And I'm going to switch colors. There, 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 and there. So let's just sketch this one. So what we can see is that this image, it looks like it slid. Anytime you use squares and rectangles, it's kind of hard to see, but it actually flipped across the y-axis. Let's look at what happened with the coordinates. All of the x values changed to their opposite, and we just looked at one while ago, and we discovered that if the x values change to their opposite, that means it is reflected over the y-axis. And the rule for that is going to be xy becomes the opposite of xy. So the y values stay the same, the x values change to their opposite. I don't say negative here because I like to say the opposite, because if it started out a negative, it's going to end up being a positive. So I think to say negative x actually makes it a little bit confusing. So I always say the opposite of x right here. So as we discussed earlier, we didn't write this down anywhere, a figure can be reflected over the x-axis, the y-axis. It can be reflected over the line y equals x, and we'll show you what that looks like, over y equals negative x, or the opposite of x. And there are an infinite number of other types of lines, horizontal and vertical, that it could be reflected over, and we're going to look at one or two of those as well. It might be reflected over something like x equals 7 or y equals negative 3. So those are. So I did a little bit of pre-work on this one, so you don't have to watch me draw all this. But if the D is the pre-image and the red is the image, then it is flipped or reflected across this green dotted line right here. So this green dotted line is called y equals x. The reason it's called y equals x is because everything that x equals, y also equals. So 1, 1, x is 2, y is 2, x is 3, y is 3, and so on. Same thing with the negative numbers. If x is negative 1, y is negative 1. If x is negative 2, y is negative 2. So this is called y equals x, and then the other one we're going to do is going this way in a minute. So I did this black rectangle, and then I flipped it across the y equals x line. And so I wanted to look at the coordinates of the ordered pairs and see what changed about them. So if A is 0, 3, A prime is 3, 0. Where D is negative 4, 3, D prime is 3, negative 4, and so on. So negative 4, 0 becomes 0, negative 4. And then 0, 0 stays the same. But what happened to them? What happened to the coordinates? Well, it looks like they just flip-flopped, didn't they? So 0, 3, 3, 0. Negative 4, 3, 3, negative 4. So if you reflect across y equals x, then what happens is xy becomes yx. So you might want to pause your video and just draw what I've drawn. I have marked the y equals x line with a yellow dotted line here. I have constructed triangle QRS, and I have put the coordinates for the ordered pairs of QRS over here. What I want you to do is reflect across the y equals x line. I would encourage you to pause your video, look at the ordered pairs, think about the rule that we just came up with for reflecting across the y equals x line, figure out what the ordered pairs are here, and then reflect this triangle and construct the triangle on the coordinate plane, and then come back and see if you did it correctly. So it should look something like this. I did not mark the points over here, but your ordered pairs should change from negative 3, 1 to 1, negative 3. So you're just going to switch the x's and the y's, and then when you write out your rule, it would be xy, and we just wrote this on the previous slide, equals yx. So they just switch places. Before I move on, I also wanted to say that when you get to Math 3, this line is going to be really important, because when we talk about inverse functions, the function has been reflected across the y equals x line. Okay, we are almost done. We have a couple more examples to do. Let's look at example 3 together. the first thing I want to look at is the fact that this says reflect this figure over the line y equals -1. So where is y equals -1? Well, -1 is right here on the y-axis. So every time, for every x, y would be -1. So that would be a horizontal line. It's our line that we want to reflect across right here. So I'm going to pause and construct this figure, and then I'll come back. So this red triangle is what my pre-image looks like. And remember, I want to reflect not over the x-axis, but over the line y equals -1. So to me, it's easier just to look at each point and say, okay, where is this thing in relation to this green dotted line? So let's look at the M first. The M is 1, 2, 3 above the green dotted line. So if we just stay on this same vertical line, and then we mark it, instead of 3 above, we mark it 3 below, because that's where it would be, then that would give us our M prime. Same thing with the P. The P is 1, 2, 3, 4 above, so we go 1, 2, 3, 4 below. And then with the R, it's 1, 2, 3 above, 1, 2, 3 below. And so that's my R prime, and then this was my P prime. So this is what our figure looks like reflected over that green line. And then what we need to do is just figure out what are those ordered pairs. The M prime is still -4. Those coordinates stay the same. The x coordinates stay the same. But then we go down to -4. -4, -4 is M prime. P prime, still -2. The x values don't change. So still -2, but then we're all the way down here at -5. And the R prime, still -1, but we're down here at, what is that, -4, I think. So no rule to state here. We're just reflecting across a horizontal line, and we just need to go point by point and just say, okay, above, it's 3 above, so I need to go 3 below and stay on that same vertical lines. The x value stays the same. So for example 4, it's directing us to reflect the figure over the line y equals -x. If you remember, the y equals x was this way. It was a positive slope, and this one is a -1 slope. So this is what y equals -x looks like. So for every y, x is the opposite of that. So I'm going to go ahead and sketch my pre-image, and then I'll come back to you. To me, this always creates sort of an optical problem, because when I'm looking at this thing like this, it doesn't look like it's reflected. But if I turn my paper kind of diagonal and I make this a horizontal line, then it really does look right. So what this is going to look like, so my M prime actually stays in the same place. So it is 1, -1. My L prime is going to become -1, -4. So let's see, where is that? -1, -4 is down here. That's my L prime. And then my K prime, need a little bit of room down here, is going to be 1, -4. So what happened is these numbers, they switch and they change to the opposite. So switch and change to the opposite. Let's go ahead and do the K. Let's see, that's going to be 1, -4, which is here, I believe. So again, like I said, when I look at this just straight on, I'm like, that doesn't look like a reflection to me. But if you kind of turn your head a little bit and you make the yellow dotted line a horizontal line, you can see that it actually is a mirror image across that line. It's just not a mirror image across any of the vertical or horizontal lines, so it kind of looks weird to your eye when you look at it, unless you turn it a little bit to the side. So let's review 4 reflections rules that we've come up with today. The first one is, if a figure is reflected across the x-axis, then xy changes to x and the opposite of y. If it is reflected across the y-axis, xy changes to the opposite of x and y stays the same. If it's reflected across that y equals x diagonal line, then xy changes to yx, so they just reverse. And then if it's reflected across the y equals negative x, or the opposite of x, oops, that should be an xy, that changes to, they reverse. So you have the y and x, but they also both change to the opposite of what they were. So those are our 4 rules. You might want to keep those in front of you as you work. I am going to let you try to work on this practice by yourself, and then we will go over this in class when you come back to class. So the first one says, reflect the figure over the line x equals negative 2. So let me just talk to you about where that line is before you start. So x equals negative 2 is x equals, I'm sorry, I'm about to do positive 2. X equals negative 2 is right here. So no matter what y equals, x equals negative 2. So it is a vertical line. So it's going to kind of overlap when you construct this figure. And then the other one, this is a reflection. So they're showing you a reflection, and they're asking you to write a rule to describe the transformation. So talk about what line did this figure reflect over. And you've got your original figure down here on the bottom, and then, or your pre-image is down here, and your image is up here. So try these by yourself and bring this, or if you come to class, bring it to class. If not, have it with you when we meet online, and we will go over these together.